you. Before I start, can you confirm me that you can see me and then you can hear me clearly? Diane makeup, hen ajan Dianeใช่ไหมครับ Diane ใช่ไหมครับ Okay, ขอบคุณครับ Okay, so good morning all of you, and very good morning to the special guest from Malaysia. So Salamat Pagi and Vanakkam if you can hear, if you can understand Tamil over there. Okay, so my name is Dr. Karthikeyan Venkatachalam. I'm an associate professor, and today I'm going to give a talk about Homechaya rice, a potential ingredient for beer production. So, okay, I'm from Surat Thani campus, so Prince of Songkla University, of course. So I belong to Faculty of Innovative Agriculture and Fishery. That's a faculty, my name, faculty, and I belong to food technology program. Okay, so some confusion over there. Okay. So what is Homechaya? So rice. Homechaya is a special name of the rice. So it is actually produced locally in Surat Thani itself. So the Chaya is a district name. So it used the name Chaya River. So sorry, the name it come from the river itself. So they produced the rice using the Chaya River. And then, so they put the name, they added the name to the rice, so Homechaya rice. So why we focused, why me and my research team focused to produce beer from Homechaya rice? Why not producing other product? Because this rice is not so familiar. So I'm not changing the slide, so I'm giving some introduction. So this is not familiar to other places. So they wanted to create something that that only produced locally, so not so commercialized, because many people in Thailand itself say they do not know about this rice. So when they pass by the Surat Thani province, so they just only get the rice as a byproduct, maybe like a souvenir or something like that. But so the farmer in that district might not have lots of opportunity to produce a commercial product. So our goal is to utilize the local product and then produce something that can be in the future can be commercialized. So that's the main scope of this idea. So rice in Thailand, maybe many of the Southeast Asian countries, they are aware of rice, that Thailand is one of the biggest producer of rice, and it has a wide varieties of rice. So it exports to many countries. So apart from rice, Thailand also produce lots of diverse agriculture production. So for example, you might have heard about durian, and then longkong, rambutan, rubber, even palm oil. So many things we can list it. So among all of these agriculture products, so the rice is one of the major agriculture crop that Thailand produce, and it's successful in sending to across the world. So rice is one of the important crop and accounts 60% of its total production. So it's major producer also, a major producer and major exporter to around the world. So we talk about rice, so it has Asia and then Southeast Asia. So we normally see without rice, maybe the day is not complete like that, you know. So we always have rice in our daily meal at least one time. If you go to South Asia, so you will see at least 3 times. So depends on where we belong, but obviously there is a meal with rice always. So rice is a staple food in many Asian countries, and then Thailand also. So in Thailand, at least one meal, the people here, we will have the rice as a staple food, our main food. Okay, there are 4 major varieties, which is famous locally and as well as internationally. Probably you know about the jasmine rice. So these are the 4 varieties: the long grain rice, jasmine rice, and glutinous rice, and whole grain rice. So these are the 4 famous varieties that you can find every corner in Thailand. So if you go to any supermarket or any local grocery stores, or even pass by, like I said, you've passed by the street or the road while you're traveling, so you could able to see all these types of rice. So what is the last one? You can see the whole grain rice. So this is very famous not because of its taste, it is because of it has lots of nutritional properties and also antioxidant properties. So that's one of the reasons that the whole grain rice is very famous. But other than that, if you go to any restaurant, you could find it. And then sticky rice, right? So if you see the sticky rice, if you come to Thailand, and you probably are aware of sticky rice, so that's one of the sorry, I mismatched the photo. Actually, this is the jasmine rice, and then this is the glutinous rice. I'm sorry about that. So this is the sticky rice that normally you can see and people eating in the morning as a breakfast. So overall,
excuse me, are you presenting your slide to us now? I can't see.
Oh really? I shared already. Like thank you. You could have stopped me before sometime. So lucky I did not finish the slide. Sorry about that. Okay. I shared already, so maybe some problem. I was showing very beautiful pictures actually. So sorry, this is very early for me. So maybe everything is not in order. Give a moment, please. Can you see now? Is it showing?
Yes, we can see now.
Okay, so welcome back again. So I'm not going to represent again, sir, but I will show you what I was trying to say. So this was my slide. So Homechaya rice, a potential ingredient for beer production. Okay, thank you. Thank you for reminding me that my screen is not shared. Okay. So I was talking about rice. So Thailand, of course, we have already learned about it. So rice is one of the major crop in Thailand. It's spreading to, actually exporting to many other countries. And so these are the rice varieties. We have 4 major rice varieties, like I said before. So these are the 4 major rice varieties. The one I was telling is, I did a mistake here. So this is actually a jasmine rice, and this is actually a glutinous rice. So I was mistaken. The figure was swapped. So so this is actually a sticky rice, and this is the normal staple rice that we use in Thailand every day for the meal. Okay, and so yeah, I start here actually. So there are 89 varieties of Thai rice documented, actually, not commercialized all of them, but documented. But like I said, in the there are 4 major varieties actually been commercialized and then been well known by many countries. But the remaining rices are, like I said, locally produced and then locally sold at, but not very well commercialized. Okay, so most of them sold as a local takeaway product in small scale with less commercial value. So like they make a vacuum packed rice, small packs, like a kilogram or maybe 500 or maybe even 300 grams of small packs, like souvenir packs, and then they sold it as auto. So here we call them a one thumb one product. So most of the undocumented or uncommercialized, non-commercialized products are sold here as an auto product. So one thumb one product. And so now, before I was starting my presentation, I gave some introduction already about Homechaya rice, right? So it is technically a local rice which is produced only in Surat province, not elsewhere, and that too only in Chaya district. So because of we using the rice, the water from Chaya river, so they give this name as a Homechaya rice. So home in Thai means flavor, so that it contains unique flavor, a distinct flavor. So, and also the color of the rice is not bright white, it is a pale brown color, and sold in an unpolished form. So normally the rice we get like jasmine rice, right? So we get it as a polished version, but this one is unpolished. So just the farmer harvest the rice, and then after that dehusk the rice, and then dehull the rice, so remove the skin of the rice, and then after that they pack and then sold it. So there is no special process was done with rice. So Homechaya rice is normally consumed as a staple food, and because of limited availability, the rice is not widely known. So not many people are aware of this rice. So because of the the production is very small. But luckily it contains lots of nutrients, especially vitamins and minerals and polyphenols. Also the typical rice property, which is gamma oryzanol and gamma aminobutyric acid. So it contains lots of good things, but the problem is production is small. So the idea of this project, which I've done, is to motivate the farmer. So in order to produce a lot, and so they can use as a commercial product that can sold all over the year. Okay, so apart from rice, what they use this rice, apart from staple food, what they use this rice for? So they actually, like I said, right, so the dehusk the rice, and then after that, they only collect the rice grain, the remaining wastage. So they also used as a byproduct. So what they mostly use for is making to, maybe probably you're aware of the salted duck egg, which is also a famous product in Chaya district. So this product, they actually take a mud and then mix with salt, and after that they cover with the salted duck egg, and on top of it they use the charcoal husk. They use they burn the Homechaya rice husk, and then after that they just cover it on it. So that's one of the property, but actually it doesn't give anything but maybe the look. So it's not helping anything with the salted duck egg, but they do not want to waste the byproduct of this rice, so they just use it as it. So it it doesn't have a high commercial value as well. Okay, so what is the alternative? We know that we have a product, but it has a high commercial possibilities, commercial product possibilities, but we do not know what exactly we can produce from it. So can we produce a milk? Obviously you can, but we do not have a high, maybe as a producer probably have, but the farmer do not have any high technology, maybe resources to buy those expensive products. So what are those alternatives? So we thought maybe why not produce a fermented beverage? So that's how this beer product come in. So this project, this topic is not motivating anyone to drink beer. Okay, so it is only for educational purpose. Okay, so don't get motivated. And drinking alcohol is very injurious to health. So I wanted to remind you that. So these are the basic process of making a beer product. So the first, everything starts with malting. Okay, so this is an overview. So I will explain it later on. So the first one is starting with malting. Okay, so in the malting, what we're trying to do, so we need to take the rice and then we trick the rice. So why do we need to trick the rice? What is the point for it? So because when we want to produce a fermented beverage, the basic ingredient for fermented product, any product, is the sugar. So if you do not have sugar, then the yeast doesn't work, and then it will not do its magic. So what the magic is actually does, so it actually take the yeast, so it take the sugar. So okay, that's sugar, you can see the glucose is entering to the yeast cell, and then it consumes as a food for itself, and then it produces waste products. So waste product, these are the two waste products we get from the yeast fermentation process, which is carbon dioxide, and then which is another one is ethanol. So carbon dioxide is all it will disappear, but we retain this ethanol. That's the main point of the fermented beverage, right? So you can also see, if you give 10 grams of sugar to the yeast, so the sugar will be consumed, and then it provide you 5 grams of ethanol back to the product. So that's how. So yeast take 100% and then give back a byproduct of remaining as a 50%. Okay, so this is the easy rough calculation that every brewer. So brewer is the person who who do the fermentation. So everyone easy to understand and calculate. So by checking the sugar amount in the product that they wanted to ferment, and then they check, okay, so it contained 20%, so we will end up with 10% of alcohol. So something like that, the rough calculation. Okay. So the preparation of malt. So why do we need to malting? So like we need to trick the rice. So the rice has lots of starch, but not a sugar. So if we wanted to chemically process or thermally process, it takes lots of time. So, but instead of doing that, we want to naturally trick the rice that it is going to be a plant in coming days. So then the rice, it will prepare itself to produce some enzymes, so that enzymes will break down all these starch inside itself and then convert them into sugar, which is the key ingredient for making this fermentation process. So, okay, so if you look at this whole process view, then you can understand that first start with malting, and then we boiling it, and then after that malting is not water, okay? So it's a dry product, but when we wanted to produce a fermented beverages, so we actually 1:3. So this is the typical ratio that we use. So 1 is the product that we wanted to ferment, and 3 is the water. So in this case, if I wanted to produce a beer with rice, so I take 1 kilogram of rice and then add 3 kilogram of water. Okay. So and then after that, we trying to boiling it, and then after that we add the yeast to ferment it. So once it fermented, it go through lots of various rigorous process, and then it will become as a beer product. So but we are not going to see all of those because of limited time availability. So I'm going to give you some detail from my research about malting, and then some beer, some information about beer. Okay. So now you can see there are colors of beers. Okay, so start from the dark to the golden color. So where this color come from? One, after we malting the grain, whatever rice or barley or wheat, whatever of choice. So after that, we have to kill them. Killing means nothing but inactivate the enzyme. So after we inactivate the enzyme, so what we are going to do, we're going to roast them. So depends on what kind of color the consumer prefer. So the producer prefer. So if I want a dark ingredient, a dark beer, so obviously my malting, after I malted my grain, so that grain I have to roast until it turned to dark color. So once I change my raw material to dark color, then if I preparing any fermented beverage, particularly we talk about beer. So if I prepare the beer, so that the beer will be in dark color. So that's how we get the color. So the color is actually contributed by the grain, actually the malted grain, which is after roasted. Okay, so one adverse point, actually. So one problem with the rice, when you wanted to produce using rice to make a beer. So what's happening when you're roasting? So if I want to make a dark color, so if I'm roasting it, what happens? It will not change to dark color. Instead, it become pop. So you know the popcorn, right? So when you put them in on the pot, and then you put some oil and then put the pop kernels, a few minutes later it will start to pop. So because of it contains lots of starch, right? The similar thing for this rice as well. So if you put them and then trying to roast them, so the rice will immediately change to become pop instead of it change to dark. Whereas for the wheat and then barley, which is the main source for European style beers, so they do not do the popping. So that's why they could achieve all these different colors. But rice, as per my experience, so we could have only golden color, not any other color. So we have one limited option. So now we see there are two types of yeast. So one is fermenting on the top, another one is fermenting in the bottom. Okay, so the bottom one, sorry, opposite. This is the top one, this is the bottom one. So the opposite one, the top one, actually easy one, very easy to do. So that's we call usually ale. Okay, so the other one is called lager. So there are two types of beer you could see in the market, especially they wrote in the bottle labeling. So the ale is one which is easy to make, not so difficult, and then we can do it very easily. Even in the warm condition we can produce, since Asia is not every place, but most of the place in Asia is warmer, so we can produce ale easily. But lager also some places colder. Even now these days producers, they use the big refrigerated storage room, so where they can control this temperature and then produce this kind of beers. So these are the different yeast. Not every yeast can use also. So maybe you have question, can I use the baking yeast to produce any alcohol? Yes, obviously you can do too, but the flavor and the alcohol content obviously not so high, because of the baking yeast is not a variant for for producing alcohol. It mostly focus on producing carbon dioxide to want to have the puffness in your bakery products, but not for the alcoholic production. So if you want to produce alcohol for real, so you need to have a brewer yeast. So that's the only choice we have. Okay, so this is the first topic. Previously, whatever I've given is the introduction. So this is the first topic, malting and kilning. So if you, I'm not going to give you all the details about the how to prepare, how to do. So only few informations, the detailed informations and methods, you could find it on this paper, which has already been published. So if you have free time, please have a look into it. And okay, so we got some good results from this paper. So I will show you what are those details. But before that, I will show you what is malting. So now the question is, if I wanted to produce a malting, can I do it without husk? So that normally a layer which is covered the wheat. Okay, for example, this is the rice. Okay, now we talk about rice. So on the top of the rice grain, we have one layer which is also called husk, right? So if I want to make a malting, so I need to have this husk on top of the rice grain. If it is not there, then we can produce the malting. So that's one of the biggest point, important point we should remember. So it need to be attached, intact with the rice grain. So now we collect this Homechaya rice and then we clean them and then shift and winnow them after, which is nothing but just removing the stones, taking some dirty things and then removing whatever it is not the rice, you remove them all, you just take the rice, okay? And then after that, we soak them for 48 hours. Why we need to soak them? Because you can see every rice grains has its own signal, the ingredient to become a plant. Okay, so now you can see one is the bigger endosperm is inside, and then embryo, which both of them been separated by a single layer of a film. Okay, so you can call scutellum. Okay, this is the name, so we do not need to know much about that. So a single layer has been separating both of them. So why we soak them? So when we soak the water, soak the rice inside the water for 48 hours. So what is actually happening? So that layer of the thin layer has been broke. So and then once it broke, both of them, endosperm and then embryo, will connect together, and then they started to think that they start the process of being a plant again. So going to be sprouting. So this case, this is the process we call them tricking. So why we tricking and triggering? So we do not want to use chemical process. We want to use natural process. The natural process is the safest process. So by doing it, what we are trying to trick the rice is we wanted to initiate the enzymes, so that enzymes will started to consume all this starch. You can see here all this starch, and then started to sprout. So how long can we do it? So if you keep them for long, it become a plant, and then you end up with nothing. So we have to make sure that how many days we can plant it. We can do this germination, which is sprouting. So we decided we will have this for 7 days, because more than 7 days, obviously the starch content inside the rice will be decreased, and then we probably do not have anything else. So that's why we stop on 7 days, a week. Okay, so how can we portion it? So we portion it like 3 days, 5 days, and 7 days. So, and then once every time interval it reaches, so we take them and then dry them at different temperature. So we want to know how fast can we dry. So because when we use the water in a grain, so this is the very risky part where it can also have a mold growth in it, or maybe another microorganism we might invite. So we do not want that. And as how long you keep them and dry slowly, that much the nutrients might lose. Okay, so we wanted to take. We do not want to take this chance, so we apply 3 different temperatures: 40, 50, and 60 degrees Celsius. Of course, it's all controlled air drying tray dryer. So we put them all inside, and then we control the temperature and time. So we able to dry them quickly. So, but we wanted to see not before 24 hours we could dry, but we wanted to compare between each other, so we keep them fixed timing, so 24 hours. And then after that we take them, we mill them, and then we not to fine powder like a grain particles, and then after that we can be able to produce this malting. Okay, so this is the stage of malting, and the temperature what we have used is called kilning. Okay, so after kilning, if you want to roast, we can have the different color of beer in the future when we ferment it, but in rice we cannot, because of it has lots of starch. It might change to popping. So this is the, you can see here 3 days the sprout level, and then 5 days the level, and then 7 days. So there are different level of growth in their sprouting. So the longer the level, the shorter the ingredient inside it has. So that's the basic concept. So, but the shorter it is, the lesser it processed. So very complication, but we have to study different bases to understand what is happening. So okay, next, malting potential. So what is mean malting potential? So how much rice we put them inside, and then how much it can be turn out to become malting. Okay, so that's what the idea of this measurement actually. So germination rate is increasing as the germination time period is increased, and then capacity of germination, so that which possibly can be malting, right? So it also increasing with the germination period. Okay, so what is the dormancy rate? The dormancy rate is like how to say, how much the water it trying to take it, how much the water is trying to take it, like how to say, during the submerging, right? So we 48 hours we keep them, right? So, and then after that, so we spray the water. So, and then every 3 days, every 3, 5 and 7 days, we wanted to check it, like how much the water is, it can hold it to do the continuing the germination process. So it is losing out its own moisture. So on every 3 and 5 days, 7 days, so longer the germination period, so it lose lots of moisture from in the grain. Okay, then diastatic potential. So it is nothing but the indication of all the biochemical in product, which is enzymes and other byproducts. We don't check anything, but we can, using this diastatic potential, we can understand how much ion is there, how much the biochemical product is been generated with this germination process. So we can understand that. So we can see that 3, 5, 7 days, so the diastatic potential is increasing. That means it's showing indication that all this the enzymes, and then it conversion into to products, like because enzymes will break the macromolecules into micromolecules, or macro thing into smaller, right? So the catalysis process, so all of them increasing with the germination time. So the malting yield, which is like how to say, if I put 100 gram of rice, and then how much I get the rice, how much gram I retain. So that's the point. So if I put 100 gram, and then if I retain all of them, or maybe 80 gram I get back, or maybe 50 gram I get back, that's a malting yield. So I put initially 100 gram of rice. So how much I could able to generate malting, and how much I get written back. So that's the calculation, because it's needed for calculating how much sample we need to use in the future for producing the beer. So this is decreasing as the germination period increasing. So that means if you longer the germination, the malting yield is very small, so which is not good as well. So malting loss, and both of them connect together. So you can see malting yield also decreasing, and also the malting loss also increasing. So these results indicate that we could not able to keep them for longer time. So we have to keep them for shorter, at least less than a week. Okay, so that's how we end up with 7 days. Hot water extract. So the longer the germination time, so you can get the hot water extract. What is mean hot water extract? How much we could extract the sugar from this germination, from this malted rice? So that, because our main point is how much we want to take the sugar, because sugar means alcohol. So that's the main point. So yeah, after we see this result, we can see the germination period actually increasing the sugar level, that by showing the hot water extract, it's increasing with the germination time. Viscous, no impact, so no problem. So what is the point of checking the viscous? So if in case when we are doing the fermentation, so they will have a clear beer and then and the unclear beer. So unclear beer, if it is high viscous, so the beer will not be clear. So it's like always having something floated around. So we wanted to see either this grain itself causing this trouble or not. We call them haze, which is the come from protein. Okay, so haze. So we wanted to stop that. So understanding, is there any differences in viscous or not? So, but obviously there is no differences. Amylolytic enzymes and sugar. So you still remember, I guess, the word I called tricking, so that we wanted to generate the enzymes in the plant, in the grain itself, rice grain itself, so that we could able to have this sugar rice nap. So you can see this alpha amylase and beta amylase activities increasing with the germination time, so that understanding that the enzymes are activated and then producing enzymes are activated and then started its function, so that we can see the total starch of this rice is tend to decrease as the germination time is germination period is increased. So that ultimately convert this total starch into reducing sugar. So the starch, the yeast can only use the sugar, basic simple sugar, which it can convert again to ethanol, alcohol. So again, that is for the starch hydrolysis enzymes. And how about the protein? Because since the grain has a protein, so because all these enzymes are the source from the protein. Okay, so not in every proteins are enzyme, but protein and enzymes are no different, because both of them are made up of amino acids anyway. So the protease enzymes, we wanted to know if there are proteins, and then there is any protease enzymes or there are not. So we found that the protease enzymes also is interestingly increasing with the germination. Increasing with the germination period, and also the soluble proteins, which we can see here, with also increasing. So there are two proteins. One is insoluble protein, soluble protein. The name I wrote here, wrote there in the previous one, haze, right? So that is actually contributed by the insoluble protein. So what about the soluble protein? It will be changed to amino acids later on. Okay, so those amino acids are the main ingredient for contributing flavor to the beer. So now you can see the germination period as the protease enzymes are increased, which convert the protein into amino acids. Now you can see the amino acid, most of the amino acids here, all of them increased with the germination period. So everything has an increasing trend, apart from some. So the decreased one probably converted into different product during the process, but most of them increased. Okay, so that's with the germination period. So as longer the longer the germination period, but then we get more mono products, which are amino acids or sugar or something like that. So later we checked about this, after we malted the rice, we wanted to look at them, and then we see the grains through under scanning electron microscope. And then we found that, so you can see the grouping means the amount of starch is present. So when it is break and then individually separated, so we can see that hydrolyzation process happened by the enzymes, and then the enzymes have broke down the starch into reducing starch into macromolecule into mono compound. Okay, so all this starch converted into sugar, you can see by observing these small fragments. Okay, so that's the idea of checking this ultrastructural observation. So we noticed down that the starch starch conversion is happening by the enzymes through the malting process. Okay, so that's the first stage. The second stage is oating and beer fermentation. So now we cut the malted rice by using them in the water, and then sprout them, and then dry them, and then mill them. Okay, and then check various properties, and then we notice that okay, those properties are highly suitable for producing beer. So then we move on to the second part, which is producing the beer, which is also published. You can see this paper, and then you can go to check if you have free time. How to produce the beer using this Homechaya rice. So again, the same process, but the first stage we have done this part, and then after that we need to oating and oat boiling. Okay, before oat boiling there is an important stage called mashing. So what is this mashing does? So it is actually converting remaining unused starch into glucose and maltose and then dextrine. So these are the three different sugars again. So we're going to use the temperature to do the process instead of enzyme. So obviously the temperature, if you look at it, very, very minute. Okay, so not so much, only warm temperature, 60, 65 and 71. So why particularly these three temperatures we have chosen? Because these are the optimum temperature for the amylolactic enzyme to work again. Okay, so it is, the enzymes are not dead yet because we use a low temperature to dry. So the enzymes are just inactivated due to less amount of moisture inside. So now we want to produce a beer. So we take the malted rice 1 kilogram and then add 3 kilogram of water. So now the moisture, the malted rice is already got enough moisture. And then we set the temperature 60, 65, 71, not all together, for 60, 30 minutes, and then 45 minutes, and then 15 minutes, something like that. So we set different time intervals. So what is actually happening in different time intervals, in different enzymes involved, and then they're producing different glucose, different monosaccharides. Okay, so you can see maltose, glucose, and dextrins is a complex sugar, which is also produced very highly supporting for the flavor of the for the beer, but other supporting for the fermentation. So now we go back to the same stage. Now we do the mashing. So this is actually mashing is in here itself. So we do the mashing, and mashing we do for 1 hour with the 1 to 2 hours with the different timing period that I show you on the previous slide. So after that, we need to do the boiling. So what is the boiling process? Because we do not want this enzyme to carry out all the time. So we want to kill the enzyme. So we're boiling it for 1 hour. So while we are boiling it, we are going to use hops. So this is the name of the herb. Okay, so hops. So this is the name of the herb. This herb, what it does, it actually giving the flavor and taste of the beer. Okay, so probably the people who have already experienced drinking beer, maybe smelling at least, so you know there is a unique taste and flavor, right? That is actually come from this herb. So if you go to European countries, though, they might have a different ingredient. Maybe they add coriander seed inside, even orange peel inside, something like that. So they use the spices to give the flavor. So when they can add the spices when they are boiling this oat. Okay, so this after 1 hour boiling, so not only you are giving the flavor to the beer, also we call them sweet oat, because now after 1 hour we use the different 60, 65, 71 10 degrees Celsius, right? So that will change the oat water to sweet water. Also we call them sweet oat. Okay, so after that you boiling it with the herb, and then the spices and herb will give the flavor. And once it cooled down to 40 degrees Celsius, so we then add the yeast of choices. Or you want to add Earl yeast, or you want to add lager yeast. So up to the fermentation process. Once you add it, it will go for fermentation. So, okay, that's the process we have done. So we got the fermented product, and the detailed information is given in my paper. So you probably have, if you have a chance, please read through the paper. You could understand how we have done the fermentation completely. Because of time limitation, so I cut down many of the parts. So now this is the difference between oat, which we processed, and then after that beer. This is the oat part. So this is the beer part. This is before fermentation, and this is after fermentation. So the main focus is want to compare. So why we chosen all these three different germination time? Because this is a new product. We have no idea which is the best to choose. So instead of predicting imaginary causes, so we just take it as all the samples and then just try it out. Okay, let's see what's the differences. We found that there are not much differences, and obviously, yeah, the content is very low in germination time when it is on third day of germination, but on 5th and 7th day of germination, if you look at it, slightly increased. But we decided through two things. One, the density of the beer, and then alcohol of the beer, and then also the viscosity of the beer. So the viscosity and density and alcohol, we chosen that because people will look at the product when it is clean and clear product, not the cloudy product. The cloudy product, no one will buy it. And then the clean product, easy to buy, is more attractive. So if you have a low density and then high density and low viscous and then high alcohol, that's a concept. So we chosen 7th day as a best target for producing commercial product. Also 5th is still fine. 5th day of germination, 7th day of germination, it still is okay compared to 3rd day. Why we don't use 3rd day? Because the amount of sugar is not sufficient if you wanted to get good flavor, high alcoholic content. So that's why we chosen this. But there are many results in this paper, but I've just chosen the physicochemical results just to want to conclude what is the best for making beer using the Homechaya rice. Okay, the conclusion. So the Homechaya rice is perfect candidate to produce malting. So without malting, there is no beer. So that's very important concept. So also the malting is also shows very promising results. So it shows this product is highly suitable for fermentation, and we can use it for beer. So, and then once we produce the beer, and we also found that the beer is good, flavorful, and good taste. And obviously, yeah, this is the preliminary stage. We need lots of optimization in the future. But from these results, we found that there are possibilities or like a scope for this Homechaya rice to convert it into a good commercial high value product in the future. And among different malting conditions, day 5 and 7 are more suitable for further practicing, as days 3 is still not sufficient for biochemical conversion, which means it convert to sugar, convert to amino acids, which is not sufficient enough as compared to the other germination time. Okay, if for people who do not drink alcohol, so what is the best product that they could make is the vinegar product. Okay, so this is focused on only beer product, not only for this rice, any rice, if people are interested to make some kind of fermented product, but because of religious strict restrictions, so you could not able to drink alcohol, but it is fine. You still can convert this produced alcohol into vinegar, because obviously you see every market now, they have distilled vinegar, right? It's nothing but sugar convert to ethanol, and then it is again go for the next fermentation stage, which is aerobic fermentation, where it change the acetic acid bacteria convert this ethanol into vinegar. So that's how we get the vinegar. Most of the vinegar product which is commercially produced or come from rice. Rice is the major source for making vinegar first, but anyway, it go through the alcoholic fermentation and then it will convert to acetic acid. So since we are here, I would like to acknowledge Prince of Songkla University Surat Thani campus, also Food Innovative and Product Development Laboratory for funding this project and equipment support to done the experiments. So I also thank you all for your patience to listen all way through, understanding a new idea, or maybe interesting or boring, but I hope you get some information about what is beer and how to make it. And sorry for some initial clicks. So I thought maybe I shared my slide, but unfortunately I didn't. So thank you again. I wish you all a very successful new year, and hope to see you in the future if you have chance to come, if the COVID allows us to see each other. Okay, one day, please welcome to PSU Surat Thani campus. Have a good day. Thank you.
Thank you very much, Associate Professor Dr. Karthikeyan Venkatachalam.
Thank you.
Do you have any question?
maybe some chat. Okay, thank you.
Do you have any question?
Maybe if not alcoholic, you can ask other questions as well if you are interested. So don't worry about beer.
Okay, if you all have no question, next morning section divided into second periods. First period, meet. She is going to give a special talk in the title of Effect of Salmonella onidensis, MR1, on my skin, corrosion under soable and insoluble phase respiratory conditions. Please welcome Ms. Nuai Atika Jamaluddin.
Thank you very much, Ms. Jarwan. Allow me to share my screen. Okay, I trust everyone can see the screen now. Okay, it is my first page of slides. Morning, greetings, Sawadika, Thailand. I would like to express my appreciation to the chair lady, Ms. Jarwan, to the IIS 20 and 22 committee for organizing today's International Interchange Symposium, and those who are from UMK. I believe some of you are from Science Materials Technology, as well as from Bioindustrial Technology, and those students from Prince Songkla University. Thank you for participating in today's event. Today, I'm so humbled to deliver my research study guided by Associate Professor Dr. Mahani Yusof and Dr. Najmi, Associate Professor Dr. Najmi Masri. They have demonstrated expertise in material science. I believe some of UMK students from material science know them very well. And also our beloved Dr. Wee Seng Kyu, he has demonstrated expertise in microbiology and geomicrobiology of Faculty of Bioengineering and Technology, University Malaysia Kelantan, to give knowledge in our research study entitled Effect of Salmonella onidensis MR1 on microbial corrosion under soluble and insoluble iron 3 respiratory conditions. So let's talk about corrosion. So what is corrosion? Just take a look at this picture and think about the process of corrosion in terms of chemical reaction between the metal and its surrounding. So for this picture, we can see that the metal, to be exact, steel pipeline under seawater, right? Which is corroded. So the question is how it can get corroded. If we narrow down a bit, the type of corrosion we are focusing is microbial corrosion. So what is microbial corrosion? Microbial corrosion is biodegradation of metallic materials. For example, just like stainless steel, alloy, where they can get degrade with the influence of microbial respiratory activity. Okay, in some condition, this bacteria can breathe metal. depending their surrounding physiology conditions. In this research study, it has been reported that in the literature, the type of bacteria group that can use iron metal for their respiration activity. So they are known as iron reducing bacteria. So in this study, we utilize Shionella onensis M1 to be our main key player of bacteria to study corrosion. So Shionella onensis M1, I mean, if you learn microbiology, Shionella onensis M1 is facultative anaerobic bacteria. Facultative anaerobic bacteria means this bacteria can use another type of metal. For example, in this study, we use iron. They can use iron instead of oxygen, where they have the capability to reduce this iron 3 to iron 2 under oxygen depletion. So bacteria Shionella onensis M1 is known for using iron 3 reduction, which that can lead to corrosion of metal. So the aim of this work is to investigate how these iron-reducing bacteria affect corrosion under soluble and insoluble iron 3 respiratory conditions. So this is a schematic diagram on how microbial corrosion. I try to make it simple. So since iron is exists in soluble, and I mean, in fact, iron is abundant in our planet. So even in soil, iron exists as soluble and insoluble iron. So the question is how this bacteria use this soluble and insoluble iron as their source of energy to survive, and they end up lead to corrosion of steel. So iron is exists in soluble and insoluble form. So bacteria will use this insoluble iron, either insoluble iron or soluble iron as their main source of energy. So the theory is once iron reducing bacteria attach to the metal surface, they will form biofilm. So due to their unique capability to reduce the insoluble iron to by transferring electron to produce soluble iron 2, the steel surface will slowly get removed, thus lead to pitting corrosion. So this is the picture how pitting corrosion occur. If you can see, the pitting refer to small hole on the steel surface. So if no action is taken over time, this hole will slowly get penetrate to the bottom of the steel. So that's how the gas or the crude oil from the steel get leaked. So at the end, or worse, it can get explode lah. It can get explode. And yeah, of course, it can be dangerous to the society. Yes. So this is the picture of soluble iron. So this is the picture of iron that we synthesize in lab. This is referred to soluble ferric citrate as I mean, this is referred to the insoluble hydrous ferric oxide, which is as you can see, the iron the precipitation of oxide layer is accumulated at the bottom of the Scott bottle. So that will be our main parameters lah to test how bacteria effect corrosion under this form of iron, either to be insoluble or soluble iron. And this is the picture of bacteria that we treat on agar plate from stock culture. For prior to corrosion experiment, we will prepare this single colony in the form of growth. So in the form of growth, in the form of liquid. So this is our methodology, how we basically designing the corrosion in the laboratory First step is we will streaking the pure culture of Shionella onensis M1 from the glycerol stock, and then we will inoculate the bacteria either with soluble iron citrate or soluble iron oxide. And then we will prior to corrosion experiment, we will immerse the metal steel coupon into the M1 media. M1 media refer to our electrolyte, electrolyte prior to corrosion experiment, and then the corroded steel will be evaluated via corrosion rates by steel mass loss method, and as you can and then will be characterized via SEM and SRD analysis. So this is our experimental design. As you can see that Shionella onensis M1 we will be cultured as iron-reducing bacteria as overnight culture. The corrosion experiment will be conducted in the serum bottle, just like in this picture, where we will spudging the nitrogen gas to create anaerobic environment, which is with the limitation of oxygen lah in the bottle. And the media that we use is minimal M1 growth. It is a modified media used to support the bacteria growth. And then we will also provide lactate as electron donor, as well to be the carbon source for bacteria to undergo their to conserve energy in the corrosion experiment. And the electron acceptor will be iron 3, where the bacteria will reduce the iron 3 to Fe2 later. And yeah, the media will be separated into soluble ferric citrate and insoluble iron oxide. So this one refer to insoluble oxide lah. So we get we have two condition of experiment to evaluate the respiratory condition of bacteria, either insoluble ferric citrate and insoluble iron oxide. So the result, okay. Since our corrosion experiment was taken up to 46 days, after 46 days of incubation with steel coupon, up to 5 poles of iron 2 product accumulated compared to the abiotic control. Abiotic control refer to the corrosion experiment without the bacteria. As you can see, Shionella onensis M1 capable of reducing iron 3 to form iron 2 as product compared to the abiotic control. So this graph refer to minimal M1 media with soluble ferric citrate and minimal M1 media with hydrous ferric oxide. If you can see, as Shionella onensis M1 shows the highest microbial Fe3 reduction with soluble ferric citrate, this one, compared to the insoluble hydrous ferric oxide. as you can see, the reading, the Fe2 concentration for ferric citrate is slightly highest compared to the hydrous ferric oxide. The highest would be 16, I think 16 millimolar compared to this one, like 7 or 7 or 7.5 millimolar hydrous ferric oxide. So slower rates during insoluble ferric oxide reduction suggest that larger surface area of oxide particle in hydrous ferric oxide would decelerate the microbial Fe3 reduction in Shwanella onensis M1. Okay, next, prior to corrosion experiment, we will proceed to the corrosion rate analysis. So as you can see, bacteria Shwanella onensis M1, iron-rich bacteria Shwanella onensis M1 accelerate corrosion rate of my steel about 0.4 to 4 millimeter per year, approximately, which is approximately 70% of steel mass loss with ferric citrate. Compare to the HFO reduction. This one referred to insoluble iron, which is 0.0942 millimeter per year with 6.62% of steel mass loss after 46 days. So consistent with the result of insoluble ferric oxide, it can be assumed that my steel are exposed to this insoluble iron, which is integrated with Shwanella onensis M1, resulted to corrosion deceleration according to our corrosion rate analysis. Then to evaluate, to examine the corrosion surface morphology of the steel coupon, we will proceed to the SEM. So as you can see, ferric citrate reduction, this one, this picture, this micrograph produce thick layer of corrosion compared to this biotic control. This is referred to the corrosion product lah, it exists as a thick layer compared to the abiotic control. Abiotic control remarkably do not produce any single of corrosion product compared to the condition with Shwanella. So this suggests that higher corrosion rate in ferric citrate reducing condition might be due to the highly concentration of corrosive citrate ion, which is 50 millimolar, as they behave as corrosion accelerator instead of corrosion inhibitor. So that makes sense lah. That makes sense why the bacteria Shwanella accelerate corrosion in ferric citrate more compared to the HFO reduction. But in insoluble iron oxide, there are abundance of poorly crystallized deposit corrosion product were observed compared to the soluble ferric citrate, this one. As you can see clearly, the crystal deposit actually composed of majorly iron and oxygen, almost like 70% lah, with minor elements, 30% of sulfur, and trace element, phosphorus and sodium, which cover only small proportion, 10%. So bacteria actually can induce this crystallized deposit compared to the soluble ferric citrate. So because we want to know what is we want to identify the type of compound that this bacteria can produce in the form of crystal deposit via corrosion experiment, we proceed to the XRD. Okay, so this is the XRD result from the corrosion product. So we take the corrosion product and then we go for XRD analysis. So as you can see, the corrosion product are majorly composed of magnetite and vivinite. Magnetite refer to iron, the reaction between iron and oxygen, and vivinite refer to iron, the reaction between iron, phosphate, and water molecule. So the idea is, the explanation behind of this corrosion is oxidation of steel, which is iron 0 valent, will get oxidized to produce iron 2, and then will be oxidized again to produce iron 3. So this bacteria will act will reduce this iron 3 into iron 2. So that's how the corrosion product of magnetite and vivinite occur. So formation of magnetite in the theory will be like iron oxide will get produced to form Fe2 and Fe2O3 ferrous oxide, and then we ferric oxide, and then we'll get oxidized again to form magnetite. Same goes to formation of vivinite. So this ferric oxide from the magnetite will slightly bound to the phosphate from the media, and then will get react to form Fe2 plus phosphate with iron molecule to form vivinite. Okay, so the explanation of this corrosion experiment is ferric citrate inoculated with Chivanilla accelerate corrosion of my steel. So the bacteria will the soluble iron citrate is actually a corrosive ion that will react to ferric hydroxide to give soluble form of complexes. So this soluble form of complexes does not remarkably forming this significant byproduct. So the bacteria will reductively dissolve the Fe3 layer on the steel compared to the insoluble iron ferroxide. So that makes sense. The Chivanilla, the abundance of vivinite and magnetite found in the insoluble iron oxide is possibly due to this bacteria cannot reduce this corrosion product lah. So that's how the byproduct of vivinite and magnetite occur. So in the literature, they reported that vivinite actually act as corrosion inhibitor, while the magnetite formed in the insoluble iron oxide are like the form on the steel surface were likely to block oxidizing agent just like oxygen against splitting corrosion. So slower rate during dissolution of this iron 3 can contribute to corrosion deceleration with insoluble iron oxide. So the conclusion is Chivanilla M1 is capable of accelerating steel corrosion under soluble Fe3 reducing respiratory condition compared to the insoluble iron. And this iron reducing bacteria accelerate corrosion of my steel to approximately 11 folds in ferric citrate in insoluble iron compared to the insoluble iron. And then the corrosion morphology and XRD analysis suggested that this bacteria utilize reductive dissolution mechanism to accelerate corrosion in soluble iron compared to the insoluble iron to further corrosion. I think this topic is quite difficult to understand because we are handling with the bacteria and we cannot see with our naked eyes, especially how the mechanism of corrosion occur. But But that's why we need to proceed with various of analysis to determine the role of this bacteria in corrosion, either to be accelerate or to be inhibited in corrosion. Anyway, I would like to acknowledge to the Faculty of Bioengineering and Technology of University of Kelantan for providing research materials and facilities back then for our research study. Okay, so thank you. If there are any question, please ask. Okay.
I have questions that I have already typed in the chat. The first question, do we normally find Shigella onidensis in environment? And the second question is, please give some suggestion for us to prevent steel corrosion by microbial growth or microbial biofilm.
Thank you to Ms. Parami for your great question, actually. So, do we normally find Shigella onidensis M1 in environment? The answer would be yes, of course. This Shigella actually can be isolated from deep sea ocean, either also in lake sediment or even in soil. Okay, and then some suggestion for us to prevent steel corrosion. So basically, if we in our current situation, corrosion actually is an inevitable phenomenon, which means we cannot actually stop corrosion, but actually we can minimize the corrosion. So that's why many of commercialized corrosion inhibitor were released every year, but some of research they reported that these commercialized corrosion inhibitors actually made up of hazardous chemicals. So the idea of our research, actually we want to open the society that corrosion that the bacteria actually got some pros and conditions to be utilized in corrosion. Of course, for the cons, the bacteria actually can lead to corrosion, but in the beneficial ideas is this bacteria can also inhibit corrosion in our environment, because this microbial biofilm actually can prevent some of corrosive ion from the commercialized product to penetrate to the metal surface. So my suggestion is to prevent steel corrosion is by using bacteria is very limited, because for me this research is still in a stage of preliminary study, because there's a lacking because we are lack of knowledge in bacteria, especially on the correlation between their respiratory physiology in corrosion lah. So yeah. So Ms. Parmi, am I answering your question?
Okay, thank you. So, so this kind of research still need to be progressed in the future, and we can know some more knowledge about steel corrosion in the future. Okay,
Yeah,
thank you.
by utilizing bacteria as corrosion inhibitor instead of using the chemicals one lah.
Okay, if you all have no questions, second period, meet. He is going to give a special talk in the title of Artificial Intelligence of Smart Agriculture with Multiple Cropping in NFT Hydroponic System. Please welcome Mr. Wellington Bunua.
Thank you, Chairman, and good morning, participants to this symposium. My name is Wellington. I'm a master degree student in applied mathematics and computing science from Songkla University, Surat, Thani campus. I will present on the topic of artificial intelligence or smart agriculture with multiple cropping in ST hydroponic system. As for the topic is the presentation, there will be two sections as well: introduction, structure, and design, and result. The short test of global result is a problem that needs to be solved accurately. Have you evaluated if the vegetable you eat are all safe? Going right in the soil in the present serious duplicity. For example, the use of pesticide with result is a higher cost and has the effect on the mineral quality of the soil. Effect of pesticide residue on vegetable crops using pesticide. This can be fatal for customer who eat vegetable contaminated with this substance. Another problem for agriculture is the migration of people resulting from poor agricultural productivity. Due to various residues in the soil, immigration of farmers into city for better right demand causing farmers to abandon agriculture, which is a very big problem. This reduce agricultural productivity and waste land useless. Researcher physicians are expected there will be a lack of resource greatly in 2050. With a projection of 9.8 million global population growth in the 2050, researchers are helping to solve the resource shortage problem. Cultivation of soil had limitation in the soil that make it difficult for plants to grow, such as poor drainage due to soil deterioration. In addition, cultivating plants in the soil takes up a lot of land for cultivation and in labor-intensive some place, such as in city cannot grow plant in the soil at all. For all reasons, so hydroponic was created. Hydroponic is aid to grow in the development plant without the needs of soil. It's no well concept the plants growing. Due to space constant and the fast, that vegetable and plant use of foods are not contaminated with various chemicals in the soil. Nowadays, there are many types of soil cultivation techniques. One offers the hydroponics researcher was John Roosevelt. He has grown plants in water by adding various soil nutrients to dissolve in the water. Planting is a demonstration that beside water, there are still many substances that plant needs. Then it starts and cannot kill the plant in the simple solution or in organic soil. There are several types of the hydroponics techniques. One of them in NFC hydroponic, which is a good technique for farmers. In this hydroponic system, special care must be taken to control the temperature of the water, acidity, and nutrient solution. Currently, approximately 3.5% of the woodlands area is controlled in greenhouse using soil cultivation technique with hydroponic nutrient solution. Technique the most popular in ASC hydroponic are where roots immerses directly in a nutrient solution flowing through in between 1 and 3 millimeter thin film. The soil flow continuously with a pump. In terms of environmental protection, plants grow faster depending on the conductivity, pH, temperature, humidity, which are indispensable factors in plant growth. In hydroponics, pH and important role in regulating plant growth or stage of growth. And the regulation of plant nutrient is part of the rapid growth of plants. Plants also need light, which is the natural cycle of plant in the phytogenesis. Environmental monitoring is a crop management. This allows plants to be grown using the Internet of Things. This allows farmers to automate hydroponics and monitor the environment with in the system. Electronic equipment can link or send information to each other via the Internet with the inputs. This is so easy that we can command and control various electronic devices through the Internet network using the Internet of Things. It is used to control the elements of plants grow in agriculture. Due to advances, climate change caused by human or nature, the crops are therefore affect and yield are low. Therefore, maintaining optimal climate by regulating humidity and temperature is important part of plant growth. The Internet of Things system is implemented in smart farm. Hydroponic cultivation using an environment controlled by the Internet of Things has grown more than 50% compared to cultivation in the soil. We develop hydroponic using the Internet of Things. The sensor is connected to the Wi-Fi module for connection and environmental monitoring. Therefore, optimization using the Internet of Things and environment monitoring. Optimization using the Internet of Things and data analytics to help simulate plant growth by controlling plants grow faster, improve agricultural efficiency, and increase productivity for users. In addition, we work aim to optimize yield and accelerate plant growth by regulating plant growth factor, reduce fertilizer, residue of plants, and let user control the water automatically without people having to measure data all the time. The advantage of NFT hydroponics is not the need for control irrigation due to the constant water contents. Due to continuous water supply, this help prevent and eliminate plant pathogen. The solution is easy to use water and nutrients still. The most efficient agriculture is empowering with automation and decision-making technologies. Because growing hydroponic requires different factors for plants to grow properly, hydroponic is an alternative for farmers to grow crops. Instead of soil to avoid pesticide, residue, or herbicide. This hydroponic planting meets the needs of farmers and consumers for clean vegetable hydroponic system. We simulate the installation structure of hydroponic system equipped with a DS322 waterproof temperature, pH, EC sensor, and light sensor. For the study before installing this sensor, we have studied the factor affecting plant growth. Every sensor installed is a key factor in regulating the environment and plant growth. Because our work aims to design and install sensor system is limited spec and manage data using a smartphone or computer with a website to control the system. The principle of the system to receive information from the sensor layer by installing it. What is sensor? Measure sensor includes temperature and humidity, light, pH, and conductivity sensor. When receiving data from the sensor layer, information will be forwarded to processing before reaching the processing layer. The measure sensor will pass the Ethernet intermediary or network layer. It's transferred to the processing layer. After the process, the data is displayed to the user through the dashboard. This is the design of hydroponic system using three dimensional images in the design. In the planning, there will be three layers of crop. The ventilation fan is stored in the room to control temperature. Now we have been experimenting with going through type of plant. The difference is amaranth and green oak. In my experiments, now I use the data from the sensor to check with the variable 1 through 7. Variable 0 means open fan, no action. Level 1 open fan, level 2 down pH, 3 as AV nutrients, 4 open fan and down pH, 5 open fan and AV nutrients, 6 down pH and AV nutrients, and 7 open fan, down pH and AV nutrients. In drinking data to be processed to make prediction, we use algorithm to process them, including KNN, random forest, Bayesian, decision tree, linear regression, multiple regression. Select the algorithm, we choose the algorithm that scales to best accuracy. Which algorithm must be used depends on all the data. Here I try to check data from a database. Which is the data we use in this test. At the beginning of the experiments, it can be seen that the decision tree algorithm gives the most accurate prediction at 98%. In the future, the accuracy of this prediction measured as more testing data is used. Just a quick recap of my future work, actually. Two types of crop, ARCO, and the data from the sensor were used to make prediction using different algorithms. The results showed that decision tree were the most accurate prediction, and in the next experiment, we'll be planting 3 different plants and use the data obtained to predict with a new algorithm to see the accuracy of the data. That's been the presentation to the end. Thank you for your attention. If you have the future question, I will be happy to talk to you at the end. Thank you.
Thank you so much, Mr. Warinthorn Bunua. Do you have any question?
I have one question. You said that in your tested hydroponic system, you plant them in a room, right? In a closed room. How can the plants get some sunlight? Or is it sunlight, the natural sunlight coming into the tested room?
Sorry, you talk again.
In your tested hydroponic system that you set the 3 layer of the plants, right? And you control everything. You control the moisture content of the room, right? Is there some sunlight coming into the room, or how can you control the light? Because the plants also need some sunlight, right?
In in pan hydroponic, the cold room has needs to 12 hours in the France.
You mean you open the light for in the room for 12 hours and then the night time for 12 hours also? I mean, is it in the green light or the closed room?
In lights.
Okay, thank you.
Do you have any question? Okay, if you all have no question, I read at the last part of today's activities. Closing remark by Assistant Professor Dr. Yuthapong Pianrod, Dean of Faculty of Science and Industrial Technology. Please welcome.
Good morning, everyone, and I'm the representative of the Dean of Faculty of Science and Industrial Technology. I'm Assistant Professor Dr. Natapon Bunnam as the Vice Deans of the Faculty of Science and Industrial Technology. On behalf of Principal of Songkla University, Surat Thani campus, especially we have the collaboration with the Faculty of Innovative Sciences in Innovative Agriculture and Fishery Resources. And normally we work with the Faculty of Science and Industrial Technology. We make some collaboration together. And especially in this mini symposium as the International Interchange Symposium with the data-driven digital transformations of agriculture, aquaculture, and global food practices. I think this is a very good chance, like a first step for us, that we can make some environment, especially in academic environment together. And I hope that in this symposium, we make a very good relationships, especially in the academic environment, that we can do it. Maybe next time, I think UMK can be the local host for the next time. But if it's okay, we will send to you. But if it's not, otherwise, we will still can be organize this for so on and so on. And I hope everyone, both of UMK and PSU Surat, can get some benefits, not only about the knowledge, but the, how to say, the duty of the research. Because when we say research, this means that we try to search again and again. And at the time that you search again and again, this means that you can find some new one and new approach. This is why we have to do research. And one of the sense of the research is not only the knowledge, but you can make some relation between your advisor and normally between the college. For example, if some of UMK master student would like to join with someone, maybe someone will contact to you. I think this is a very main point of the one idea that you can make some collaboration. And as I told you yesterday, I think this all of you is a world-class student, and you will get the world-class activity. And after you graduate, you will be the world-class workers in the world. I hope that you can do your best and hope to see you again next time. Thank you everyone who coming to join us, and thank you especially the workers, MC, Ms. Charuan, and our advisor, Associate Professor Dr. Somwang, Assistant Professor Dr. Parami, Dr. Surat, Dr. Krisada, and another advisor that who try to encourage us to do this. And now we finish our symposium already. Thank you so much, and good luck for any chance of your life. Thank you. I think we can take a photo. I like to take a photo. Can you turn on your camera? I say it again because I say it yesterday. Can you turn on your camera? Okay, try to turn on your camera and we'll take a group photo, the last group photo for this symposium. That's it. Wow, they tried too. That's good. Wow, you have the new trays. I never said before. I remember you. And it's a Thai student too. เปิดกล้องนะครับเปิดกล้องเดี๋ยวถ่ายรูปด้วยกันนะครับ Okay, let's have someone who try to catch our group photo. Okay, I will say 3, 2, 1, and after that you have to don't do like this. Don't movement because your face is blur now. Okay. On your mark, set 1, 2, 3. You can make something. Thumb up. In Thai, we call susu. In anything you want to do it. Okay, 1, 2, 3. Okay, keep fixed for 5 minutes. Okay, that's all. Thank you so much. Okay, I send you back to M.
We have come to the end of this breathtaking event. On behalf of the organized team, we would like to thank our distinguished guests for gracing this our ceremony of the IIS 2022. Terima kasih ขอบคุณค่ะ
So now our organizing committee has already put the link for e-certification in the chat box. Could you please everyone click the link and fill in the form for your e-certificate? Thank you.
This is how fast YouTube is with Brave. Notice how there's no pre-roll ads? And here's how
Google Form มีปัญหานะครับทีมที่ทำ Google Form ต้องเอา permission ของมหาลัยออกก่อนนะครับไม่งั้นจาก UMK จะเข้ามากรอกไม่ได้นะครับ
แล้วก็ middle name ด้วยค่ะ middle name ต้องเอาออกนะคะเพราะว่าคนไทยไม่มี middle name ค่ะไม่ต้องบังคับกรอกนะคะ
So for all participants, please wait a moment. We will edit the form for you to fill the form. So sorry for your inconvenience. Please wait a moment, and after that, we will send the new one. And after you fill the form in the Google form, you can leave this Zoom directly. Thank you. So sorry I have to say in Thai คนที่ทำฟอร์มอะครับพอดีว่ายังใส่ permit ใน setting นะครับยังเซตให้เข้า Gmail ดังนั้นเนี่ยทางมาเลจะเข้าไม่ได้นะครับเพราะว่าเขาไม่ได้ใช้ Gmail เป็นหลักนะครับต้องปลดนอกจาก PSU แล้วต้องปลดการเข้าถึงของ Gmail ด้วยครับ so maybe I had to say sorry again. We have a lot of permission in Google Form, so we will try to edit as fast as possible. Please wait a moment. Thank you.ได้ไหมครับได้ไม่ได้ส่งสัญญาณด้วยนะครับ Okay, and for the Malaysian persons, so try to send the form with this link. If you can do it, please tell us. Okay, all right. So try to check and correct your name, surname, and affiliation. Affiliation means you can put the department and your universities, and we will send the certificate via email. So please try to correct all the alphabet that you put it. Thank you. And happy to see you. So come to Thailand, and if you would like to ask for going to your university, send out to email. Invite us. We would like to go outside. Ajahn Parami is smiling now because of we want to go right now. Don't want to stay only in the Surat Thani. Camilla, I we miss you. Thank you so much. So if you finish, especially in participant, if you finish your correct and fill the form, you can leave this Zoom meeting. Thank you. Thank you, Fatin. See you next time. Has anyone didn't fill the form, especially HJR, Ner, Ishahid, Amiru, Cuba, and Juan? Is there any problem? You can tell us. We will support you.โค้ชครับอาจารย์ขอสิทธิ์โค้ชด้วยได้ไหมครับโค้ชจ๋าขอสิทธิ์โค้ชด้วยนะครับไม่ให้สิทธิ์เราจะแฮกแล้วนะเอามือไวนะบอกไว้ก่อนนะไม่ให้ได้เดี๋ยวแฮก
เรคคอร์ดดิ้งได้แล้วค่ะ
โค้ชไม่ทำให้เราจะทำเองแล้วนะโค้ชอยู่ไหมนี่ พูดไทยแล้วนะยังโค้ชอยู่ไหนอะบุ๋มใครคือโค้ชเนี่ย
พี่เจมกำลังทำอยู่ค่ะ
ทำอะไรอีกไม่ต้องทำ Google Form แล้ว
ภาพหาไม่เจอ
ไอ้ข้างล่างอะตรงเรคคอร์ดอะค่ะกด stop recording อะค่ะ